All right, last video of the 2019-2020 school year. This is your warm-up. I want you guys to pause it and try it. You can use your calculator, so I want you to come here to your mode. And then notice on this third line, it says radian or degrees. So you're going to want to put that mode in degrees. If you didn't know how to do that, and then you want to exit out of that. And you see you have sine, cosine, and tangent there. So take a moment and go through this. So hopefully you took a moment and used your calculator and filled this out, and I hope you found something interesting on it. If I did cosine 80, I get 0.174 if I go out to the thousands place. And now if I do cosine of 70 degrees, and then we want to put times cosine of 10 degrees, and then we want minus sine of 70 times sine of 10, I get the exact same answer. And mathematicians found that if you broke up an angle that was given that maybe wasn't a special right triangle, or you had no way of figuring it out without a calculator, or for whatever reason, that they found that if you broke it up into its component pieces, you could do 70-10, you could try this with 50-30, anything that equals the 80 degrees, that if you followed a formula, you would get the same answer. And we call this formula the sum and difference formula. So you're going to want to make sure you have these in your notes somewhere. And the sum and difference formula, really the only thing it's good for is if you didn't have a calculator, you wanted to find the exact values, you could break your two angles, alpha and beta, into two special right triangles that you know something about. It doesn't always work, but sometimes it does. So if we just go back to our warm-up really quick before we finish, we'll go back to that slide, so don't worry. We see that we broke 80 degrees into two angles. So this is like alpha and this is beta. So instead of using theta, we're using two different Greek letters. Okay. So there are three versions of your sum and difference formulas. So sum meaning I'm adding the two angles, difference meaning I'm subtracting the two angles to get whatever my angle was. And we'll have a couple examples of that. So notice if you use the cosine, the sum and difference of cosine, if you have a plus here, it's an opposite sign here. So notice the pattern, cosine alpha times cosine beta. If I wanted to find the addition of these two, I would have minus sine alpha sine beta. Now, if my alpha and beta, I was subtracting each other, then it would be addition. That's why I have these highlighted, because the signs are reversed here. So be really careful on that. If I do the sum and difference formula with sine, notice that the signs are the same, but I have a combination of sine alpha cosine beta and cosine alpha sine beta. And then tangent is got a combination of both. So if I'm adding my two angles, the signs match up on the numerator, but they are opposite in the denominator. And again, this is something that is important to calculus. It's why we're kind of finishing our year off with it for those of you who are going on to Calc 1 or more likely Calc AB and then maybe BC at some point. All right, so here's how it works. Finding exact values for non-standard angles. Let's say someone wants you to find cosine of 15 degrees and they want the exact values. So of course you could stick it in your calculator and get cosine of 15 and get some crazy decimal. But we can also make 15 degrees out of two special right triangles. And so in that case, we would use cosine of 45 minus 30. 45 minus 30 gives me the 15. So this is a difference. So if I want to do cosine of 45 minus 30, the sum and difference formula says I'm going to have cosine of 45 times cosine of 30, but then it's going to be opposite here. That's what I meant by those sign changes. Then it's going to be plus sine of 45 sine 30. And we know these values from the unit circle, so this would be a great time to pull out your unit circle. Cosine of 45 degrees, any cosine value on the unit circle is your x value, sine is your y value. So here we're going to have root 2 over 2, and then we're going to have that times cosine of 30. So cosine of 30 gives me the root 3 over 2. Plus sine of 45 is root 2 over 2 again, and sine of 30 is 1/2. So that's what we're going to have for this first one. So when I multiply these, I get root 6 over 4, and here I get root 2 over 4. So my final answer is really root 6 plus root 2 over 4 is my exact value of cosine of 15 degrees. I want you guys to pause and try that with cosine of 75, and notice they already figured out the angles for you. Okay, so this was the sum formula. So hopefully you wrote it out like this. Cosine of 45 plus 30 was going to equal cosine of 45 times cosine of 30 minus sine of 45 sine of 30. So root 2 over 2 times root 3 over 2. There's a lot of similarities between these two. Minus root 2 over 2 and 1/2. So in this case, you should have gotten root 6 minus root 2 all over 4. Right. These are pretty nice. Example 1 is pretty nice because they split that angle up for us, but what if they don't do that? What if you're just given 165 degrees and you have to come up with 2 special right triangles that would give you that? What would you do? So look how they broke up. 120 isn't a special right triangle, but it's 60 plus 60. So I know this one, just to break these up, try to think special right triangles. I know that I'm going to have a 45 in it plus 120. This is just a practice to get you to think this way. 120 isn't a special right triangle either. 105, well, if I take 45 degrees, because that has to be one of the special right triangles, I could have 45 plus, what is that, 70? Or you could do it another way. You could have subtraction. So this is going to be 45 plus 210. And all of those you can find those on your unit circle as well. And then it gets a little harder with radians. I don't know that we're going to do it with radians on this, but definitely with degrees, you'll have some tasks with that. Just want to keep your video not from being like 30 minutes long. All right, so here's cosine of 135 degrees. Go ahead and try this. Think, what 2 angles could I add together or subtract from one another that I would know those values from the unit circle? All right, so for me, I said we would have cosine of 90 plus 45. And if I broke that into the sum formula for cosine, I would have cosine of 90 times cosine of 45, and then it would be minus, because the signs are opposite, then I would have minus cosine of 90 times, oh, sorry, not cosine of 90, sine of 90 times sine of 45. So cosine at 90 degrees on the unit circle is 0. So even though we know this is root 2 over 2, it's going to kind of knock that out. Sine of 90, however, is 1. And sine of 45 is root 2 over 2. So we end up with 0 minus root 2 over 2. So this must just equal a negative root 2 over 2. And you could check your answer on the calculator by looking at cosine of 135 degrees. So you're going to have some problems after this task, both like this where you have to come up with how you add them together, or like the previous example where it gave it to you. All right. The other way you might see this is they've given the expression. They've already spread it out, and you need to write it as a single expression. So let's bring back our formula sheet out. And how you figure this out is you figure out which pattern is it fitting here. Well, I have cosine with cosine and sine with sine. So I must be doing the sum or difference formula of cosine. And I see that I have subtraction. So I must be adding them together because my signs would be opposite. All right. So then once you figure out which sum and difference formula you're going to use, you can label your angles. This is alpha, this is beta. Alpha, beta. So I am trying to put it into this format, alpha plus beta. So I'm going to have cosine of 57 plus 78. No, I'm not very good at addition. You guys all know that. So I'm using my calculator so I don't make a mistake. And when I do that, I get cosine of 135 degrees, which you should be able to look on your unit circle and know that that would be root 2 over 2, or a negative root 2 over 2. All right. I want you guys to try writing this as a single expression in cosine. So notice we already told you it's subtraction, and you're just going to combine the fractions. So this theta over 3 confuses some people. It's really like saying 1/3 theta. So you're not going to be able to actually come up with a value, but you should be able to come up with a single expression. So you should be using the sum formula of cosine. All right, guys, this one's crazy. We know this is alpha and beta, alpha and beta. Since it was subtraction, I said we were using the sum of cosine, so we must have the sum of alpha plus beta. So if I plug in my values, even though I still have unknowns because they have a variable theta, I have theta over 3 plus theta over 6, and I can make this have a common denominator. So this is really cosine of 2 theta over 6 plus theta over 6. So I would get cosine of 3 theta over 6. And you guys should guess that that can be reduced to cosine of theta over 2. All right, that's it. This is your very last task that you have to do. Please let me know if you have any questions. And it's just, again, it's been my honor having all of you guys as my students. I couldn't have asked for better classes.